Dear students, welcome to the channel Cambridge ChemG Guide to learn Igcse Organic Chemistry. In this video we will continue the concept of formulae, functional groups in more detail. We will cover the following topic. Let's start with the molecular formula. A molecular formula serves as a brief depiction of a chemical compound's composition. It reveals the precise number of atoms for each element present in a single molecule of that compound. For example, the molecular formula for butane is C4H10, which indicate 4 carbon atoms and 10 hydrogen atoms. Now let's talk about the displayed formula. The displayed formula illustrates the spatial arrangement of all atoms and bonds within a molecule. For example, the displayed formula for butane is shown below. This formula reveals important information about the compound. It contains 4 carbon atoms. It includes 10 hydrogen atoms. It consists only single bonds. Now what is the structural formula? Structural formulae provide sufficient information to clarify the structure, although many of the actual covalent bonds are left out. For example, the displayed formula for butane is shown below. Now let's discuss what are structural isomers. Structural isomers are compounds that share the same molecular formula but differ in their structural formulas. For instance, butane, C4H10, has 2 distinct structural isomers. One is butane and another is 2-methylpropane. Let's take another example, butene, which can also exist in 2 structural isomers. 1-butene and 2-butene. Let's talk about functional group. Functional groups are atoms or groups of atoms within a molecule that determine its characteristic chemical properties and reactions of a homologous series. Following table shows the functional groups according to homologous series. Alkane has no functional group, while functional group for alkene is carbon-carbon double bond for alcohol O group, and for carboxylic acid COOH group. Now we are going to discuss the general formula of alkane, that is CnH2n plus 2, where N equals 1, 2, 3 and so on. N shows number of carbon atom. 2n plus 2 shows number of hydrogen atom. For example, methane, CH4, where N equals 1 carbon atom. 2n plus 2 equals 4 hydrogen atom. Now let's discuss general formula alkene. That is CnH2n. The value of N can be 1, 2, 3 and so on. N shows number of carbon atom while 2n indicate number of hydrogen atom. For example, ethene, C2H4, where N equals 2 carbon atom. 2n equals 2, 2 equals 4 hydrogen atom. Now let's discuss the general formula alcohol, that is CnH2n plus 1 OH. The value of N can be 1, 2, 3 and so on. N shows number of carbon atom. 2n plus 1 shows number of hydrogen atom and 1 hydroxyl group OH. For example, ethanol, C2H5OH, where N equals 2 carbon atom. 2n plus 1 equals 2, 2 plus 1 equals 5 hydrogen atom. Now let's discuss the general formula of carboxylic acid. That is CnH2n plus 1 COOH. The value of N can be 1, 2, 3 and so on. N shows number of carbon atom. 2n plus 1 shows number of hydrogen atom and 1 carboxyl group COOH. For example, ethanoic acid, CH3COOH, where N equals 1 carbon atom. 2n plus 1 equals 2, 1, plus 1 equals 3 hydrogen atom. Here you have seen that number of carbon was taken 1 for formula. Carbon of carboxyl group, COOH, is not included for taking the value of N. Now let's discuss 2 additional terminologies, saturated unsaturated compounds. Saturated compounds are organic substances characterized by the presence of only single covalent bonds connecting the carbon atoms. Methane, CH4, serves as a typical example of a saturated compound. In its structure, 4 hydrogen atoms are linked to a single carbon atom, with all connections being single covalent bonds. Unsaturated compounds are organic substances that feature at least one double or triple bond connecting carbon atoms. Ethene, C2H4, serves as an example of an unsaturated compound, characterized by a double bond between its 2 carbon atoms. Thanks for watching. If you enjoyed this video, please like and subscribe so you don't miss what's next.